Hello students, today I am going to deliver a lecture on the topic of dense and the sparse indexing. Students, we all know the indexing techniques. By the help of index, we can reduce the number of access to access a single record. Okay, so in dense indexing, there there will be a a there will be an entry correspond to every record of a database in an index file. Okay, so as you can see here, we have an index file and the record file. Okay, and in the index file, every search key is present. Okay, so in dash indexing, we put index entry for every search key value. Okay. So here the search key attribute is a country name. So every country name will be present in the index file. Okay. And we all know the index file, each entry in index file just consists of the two fields. One will be the key attribute, one will be the attribute over which we perform the search operation, and second field will be the pointer to a record. Okay, to a record of the database. Okay, the base address of the record. So that dense indexing makes the access faster, because in just one access, why just one access, we can directly reach to the record by the help of pointer. Okay, but the disadvantage of dense indexing is that the index file will be very large, because correspond to every record of a database there will be an entry in the index file, and if the number of entries will be high, then the number of blocks we require more will be more, right? So if the number of blocks will be high, then definitely uh, we need to access the more number of blocks in the worst case to access the search entry, and after accessing the search entry we can directly reach to the desired record by the help of pointer. Okay, so you can see here, correspond to every search key there will be a index entry in the index file. Okay, here only two blocks are required. As you can see in the index file, only two blocks are there, because the each entry in the index file will be very small, and correspond sorry, for to store every entry we need very small number of blocks. Okay, so we prefer the dense indexing always when our record file is not sorted, because we don't know where the record is. Therefore we always we need to we need to keep track every record. Okay, since our file here is not sorted, as you can see here, first 1 5 4 2 6 3, here the file is not in a sorted order, is not in a sorted order. Therefore we need to use here the dense indexing. Okay, let's discuss the access time in dense indexing. So what we do here, whenever we need to access a record, first we will go to the index file. Okay, and we all know the entries are in the index file is also stored in the blocks. Okay, so we need to access the block. Okay, if our index file is having m blocks, then we need to access log m, log to the base m access in the worst case to access the entry on the index file. Why? Because the file is always will always be in a sorted order. Therefore, we need to access. We need to need to perform access about log n times in the worst case using binary search algorithm. After accessing the search entry, we need to perform one more access to access the record file. Okay, because through a pointer we will reach to a block in which our desired record is present. Okay, so to get that record, we need to access that block also. So therefore, the total access time will be equal to the log to the base n plus 1. Next one is the sparse indexing. On the basis of ordering, the second categorization of the indexing is the sparse indexing. In sparse indexing, there will be an entry correspond to a set of records in a record file. Correspond to a set of records of a record file, there will be a single entry in the index file. Means that correspond to every record, there will be no entry in an index file. So definitely in a sparse indexing, the number of entries will be very less compared to the dense indexing. And in a sparse indexing, the size of the index file will be small and the less number of blocks will be required to store the index. So definitely it will reduce the access time, the input output cost. Okay. So now question arises, where to use the sparse indexing? You can see here we have a record file which is in sorted order. Okay, you can see the 1, 2, 3, then in the next block 4, 5, 6, in the next block 7, 8, 9. Okay, and you can see also here in the next file very small number of index entries are there. Okay, correspond to the all entries of the first block, only one correspond to the all records of first block of a record file. There is only one entry in the index file, and that entry always be point to the base address of the block, or can say the first record of that block. A search key 1 is pointing to the record 1, and next entry is of 4 because it is pointing to the first record of the block 2, which is the record number record having the entry 4. Okay. So in sparse indexing, only one entry will be there correspond to the all records of a single block, and that is why here the index file will be smaller and the less number of blocks will be required compared to the dense indexing. So we use always sparse indexing whenever we have a sorted file. Whenever we search for the record 2 here, whenever we do search for the record 2, then what we do here, first we will reach to the block 1 through the search key 1, because the record 2 uh, because the record having entry 2 lie between 1 and 4. Okay, so we will start with the 1. Okay, in the index file we will start with the search key 1. Okay, because the key attribute value of 2 lie between 1 and 4. Okay, so we start with the 1. Through a pointer we will reach to the block 1. Okay, so when we reach to the block at the base address, we will search in sequential manner. First we will search whether it is equal to the first record is equal to the 2 or not. If it is not, then it will move down side to the next block, sorry, to the next record, and the next record is 2. So here match is performed. Okay, so the value is matched now, and our desired record is found, and we can get that record from the data from the block. Okay, so this is how sparse indexing works. Let's discuss the access time. Access time will be similar, very much similar to the dense indexing. Here, the access time is similar to the dense indexing because here access time is log n plus 1, where n is the number of blocks in the index block. But here the n will be, the value of n will be smaller than the number of index block over dense indexing, because here every because here the an index file correspond to a set of records, there is a single entry, but in the dense indexing correspond to every record there is an entry in the index file. So that's all for the today's session. In the next lecture we will discuss the further categorization of the indexing technique. Thank you.